Here are 3 ways to combine 3 with 3. 3 plus 3 is 6. 3 times 3 is 9. 3 to the power of 3 is 27. Now look at how each one is made. Multiplication is addition, done repeatedly. Exponentiation is multiplication, done repeatedly. Every rung is the rung below it, applied again and again. School teaches you 3 rungs of this ladder and then stops. The ladder does not stop. There is no reason it should. If exponentiation is repeated multiplication, then something must be repeated exponentiation, and something must be repeated that. The whole family has a name. They are called hyperoperations, and they are numbered. Addition is 1. Multiplication is 2. Exponentiation is 3. The 4th is called tetration. The 5th is called pentation. And nobody stops there either. There is a pattern at the bottom of each rung too. Add 0 to a number, and you get the number back. Multiply by 0, and you get 0. Raise to the power 0, and you get 1. Titrate to a height of 0, and you get 1 again. And from the 3rd rung upward, it is always 1. The ladder is more organized than it first looks. Before we can climb, there is a problem to fix. Repeated multiplication is unambiguous. 2 times 2 times 2 is 8, whichever pair you do first. Exponentiation is not like that. Take 3 to the 3 to the 3. Work left to right and you get 3 cubed, then cubed again, which is 19,683. Work right to left and you get 3 to the 27th, which is over 7.5 trillion. The same 3 symbols. The answers differ by a factor of 387 million. So which one do we mean? The convention is to read the tower downward, from the top. And that is not an arbitrary choice. It is the only choice that gives you something new. Reading left to right collapses. 3 cubed cubed is just 3 to the 9, an ordinary power. Reading downward is the direction that escapes. A tower of A's, n stories high, is a tetrated to the n. That is the 4th rung. Watch it with the friendliest base there is. 2, 1 story, is 2. 2 stories is 2 squared, 4. 3 stories is 2 to the 4th, 16. 4 stories is 2 to the 16th, 65,536. 5 stories is 2, raised to that. And that number has 19,729 digits. Add 1 more story, and the number of digits itself has 19,000 digits. Now change the base from 2 to 3. 3 stories is already 7.5 trillion. 4 stories is 3, raised to 7.5 trillion. Written out, that number runs to about 3.5 trillion digits. Print it at 3,000 digits a page, and you would need 1.2 billion pages. That was 1 extra story. Ordinary notation gives up here, so Donald Knuth replaced it. 1 arrow means exponentiation. 2 arrows mean tetration. 3 arrows mean pentation. The number of arrows is the rung on the ladder, and the rule never changes. To work out n arrows, you repeat the operation with 1 arrow fewer. And here is what climbing costs you. 2 to the power 3 is 8. 2 to the power 3.5 is about 11.31. Exponents do not have to be whole numbers. Stories do. A tower 2.5 floors high is not something anyone has managed to define. There are several proposals, they disagree with each other, and none of them has won. Tetration at fractional heights is still an open question. So what does pentation actually do? 2 3 arrows, 3 says, titrate 2 by itself 3 times. Work from the right. 2 arrows, 2 is 4. So we need 2 arrows, 4. And that is a 4-story tower of 2s, which we have already built. 65,536. That is the surprise. The first interesting pentation is small enough to write on screen. It does not stay small. 2 3 arrows, 4 means 2 arrows, 65,536. a tower of 2s, 65,000 stories high, and 3 arrows, 3 is a tower of 3s, 7.5 trillion stories high. Not a number with 7 trillion digits, a tower with 7 trillion floors. Add one more arrow and you arrive at the number that made all of this famous. Graham's number begins with 4 arrows, 3. Then it takes that answer and uses it as the number of arrows for the next step. Then it does that again. 64 times. There is no way to write the result down. There is only a recipe for building it. Every step so far has gone the same way, up and violently. 4 symbols were enough to leave the observable universe behind. So here is the opposite question, and it has a much stranger answer. What if we never stop the tower at all and shrink the base instead? Take a number and build the tower forever. X to the X to the X with no top floor. For most numbers this is nonsense. It simply runs away. Try it with 3 and it is gone inside 4 stories. But for some bases something else happens. The tower settles, it climbs towards a finite number, and then it stays there. Try the square root of 2, about 1.414. 1 story gives 1.41, 2 stories 1.63, 3 stories 1.76, then 1.84, 1.89, 1.93. It is still climbing, but it is slowing down, and it converges exactly on 2. An infinitely tall tower of square roots of 2 equals 2. There is something hiding in that. If the whole tower equals y, then x to the y must also equal y, because the tower contains itself. Put in the square root of 2 and solve. Y equals 2 works, but y equals 4 works just as well. The square root of 2 to the 4th power is 4. So why does the tower choose 2? Because 2 pulls and 4 pushes. Start near 2 and the step takes you closer. Start near 4 and it takes you away. Only one of the 2 answers is stable. So which bases work at all? Turn the equation round. If y equals x to the y, then x equals y to the 1 over y. And that function has a maximum. It peaks at y equals e, and its height there is e to the 1 over e. So that is the largest base that can possibly work. 1.4447. Above it, nothing converges. There is a floor as well, at e to the minus e, about 0.066, below which the tower stops settling and starts oscillating. And the edge is sharp. Exactly at 1.4447, the tower converges, and it converges to e. Nudge the base up to 1.45, barely past it, and the same tower leaves the screen entirely. Euler presented all of this to the St. Petersburg Academy in 1777. So the ladder runs in both directions. Climb it, and 3 small numbers become larger than anything the universe has room for. Hold it still and shrink the base, and an infinitely tall tower settles quietly on 2. Both of those come out of the same instruction. Do it again. So that is the ladder. Addition, multiplication, exponentiation, tetration, pentation, and it keeps going with no top rung. Every number you have just seen was computed for this video, not quoted from anywhere. If you want mathematics drawn rather than described, subscribe, and I will see you in the next one.